Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on Kano. Okay, so let's see. So today, gonna be continuing to build out the scripting language, a Kano script, if you will. So yesterday, we made it so we can define variables, right? So let x, it could be an integer or a float. So let's do like 165, sure. And then we can echo. We can either echo out a variable, so echo x 165, or we can echo a string. So this is a string, and it will echo that. That's pretty much what we've got. Today, I would like to make it so we can have we can have expressions, right? So let y equal say 12 plus 5, right? Something like that. So we're gonna need to actually properly parse it, like build out the syntax tree, and then interpret it based upon that, rather than just interpreting directly from tokens like how we are now. So that is the plan. That's the plan for today. Let me get these source. There you go. Okay. Let me not see. So let's see. Yeah, let's start in defs. Defs. Okay. Let's see. So we're gonna need a tree. So I'll just put it down here, right? Okay. Type def struct. AST. There we go. So that's what we're gonna have. So it's gonna have just be like a binary tree. I don't think we have to get too complex about it. So just have a left and a right, right? So we'll have let's see. So a node, right? Yeah. Is that how I want to do it, or is it gonna be each one is also that? So it should probably just be called a node. Yeah. So it's like that. That makes more sense than having yeah. So that's what we'll have is nodes. And then each node is gonna have to have its own value, right? The value, let's see, node value. Yeah. So we'll make a node value then. And this should probably be a union, right? Node value. So we can have a couple different things here. So it could be say like a binary expression where you have a left and a right and then an operator. Or it could be let's see, it could be a single value. So like just an integer or whatever. Yeah, let's do that. So we're gonna need to define a few things here. Okay. Really become more building a programming language than a text editor, but that's okay. So binary expression, right? And then we'll have let's see, we'll have expression. Okay, the expression. Let's see. So this could have just a single value, right? Let's see. Should it be perhaps variable value, right? Let's see. I'm trying to think how to build it out. It's not really something I've done before, so it's kind of like a learning experience, right? But this will have right? I'll build it in terms of ints first, and then we'll have more advanced data types. Whoops. Not sure what happened there, but I have to start over now. Okay. Let's try that again. This is the tree. Yo. Node left. Node right. It's the binary tree. And then, yeah, we'll have binary expression. Expression. And then we also need the email for the not type then. Not email, but email. Node val. Node val value. Okay, so yeah, this could be an expression. Binary expression as a. Okay, so these can have a few different things. So yeah, this has int right, right, int right, and then it also has an operator. Is that what it's called? Like plus, minus, that kind of thing. So I'll need probably just an enum for that. So yeah, we could have plus, plus, op minus, op multiply, and OK divide, right? Something like that. And then expression with just a single value. And then we also need like a keyword. Keyword. Yeah. So this just has the keyword. So we have an enum with the keywords, right? But it's not in here, is it? Let's see. Most of the enums are defined up at the top. So a view type. Yeah. So we don't have it defined here. So how do we want to do that exactly? Keyword. So that should probably be, maybe this all should even be not even defined in here, but instead define let's see, define in here with all the other stuff. So I think that actually makes sense. I'm gonna copy it over. Okay, yeah. So just like this stuff can be in there. I think that makes more sense actually. Okay. Yeah. Let's try that. Uh-huh. Okay. And then we have more stuff here. So keyword probably can have a command type, yeah. Okay, so yeah, then we need as keyword as well. I'm trying to think of all the different possible things. Where's the unit? Down here. Keyword as keyword. Which that really just has the type, so maybe we don't need a struct for that. Instead, it could just be the command type as keyword, you know? Yeah, instead of wrapping it in a struct like that. Okay, what else? What else do we have? So let's go through these. So we have, these are like keywords. These are operators, so that is in there. This is another keyword. I should have organized these a bit better. Save, that is, well, these, those are basically keywords, right? Like, W for writing, stuff like that. Save exit, yes. String. So we need, like, literals, which, okay. So TT string, that would probably be a part of the, well, yeah, we can have literals and then identifiers as well as part of it. So let's see. What would, so this literal, that could have a couple different types. So it'll be a literal val. Yeah. Okay. Type def. So a literal, well, okay, maybe it should be specifically string instead. String like that. And it'll just have, and well, should even be like a string view. Is that a good idea? Because then we have the sign as well. That's probably useful. Well, yeah, let's do that. String view. Got it. Okay, so we have a string literal, and then we also need an identifier. Identifier. So that has a string view name. So it's basically a variable, right? And then it has a value. So yeah, so we'll give it in value for now. Okay, so we need stir literal, and that should cover, I think, everything. At stir, and then we can have identifier as ID. Okay, so these are all of the values that we could have. And then this is the tree. So we'll build out the tree where each node has a value, which is any one of these. And then based on, well, we should have the type as well. So node type. So let's just let's make like the node for that, right? So it could be let's see. Yeah, this is node type, right? So this can be node extra, node binary, node keyword, node stir, and node item. So then we know what the type is, right? So each one has a value type, and then a left and a right. We can build out based on that. So, yeah, now we need to actually, after we lex it, we need to parse it, right? So let's see. Here's the lexing, and we do lex like expressions right now. So we should be good in terms of that. So how do we call this? We call lex command. Let's just like do a parse command right in here after we do that. On the, well, do we want to do that? No. So let's actually exit this. Let's go to main.c. And what we call it, lex command. Yeah, right here. And we do this. So we execute a command based on the command stuff. So execute command, maybe that could even be where we do the parsing. Like call a function from the not the lex, but execute. Okay, yeah. So like before we do all this, we just sort of do parse command. At least temporarily. This, yeah, we'll do it like this. So we don't need the buffer or the state for this, but we do need the command and then the command size. And then yeah, and then we can use stuff here. Based on that. But for now we'll make this and then we'll think about what it would return, right? Parse command size. Okay, and this is actually so this command is going to be command token. So it's an array of them. It's an array of tokens, right? And then it's just the size, the number of tokens. Yeah, so we will go through that. And then this execute command is actually going to be like traversing it. So yeah, we probably don't want to actually call it like that, but whatever, it's fine. It's fine for now. Okay. Right. So this is really where stuff is going to happen. So I'm going to change stuff around, but this is what we're going to get. So basically we need to iterate over it, right? I is less than command size. I plus plus. Okay, yeah. So this is an array that we have right here. And then, depending, well, really, we don't need to iterate over the whole thing. We really need to do similar to what we're doing in here, just switch statement. Switch on the type, right? And then, depending on the type of it, we have to form the syntax tree. So this is really going to return, it's going to return a node. Pointer to it. And that is going to be the head, the root of the syntax tree, right? Which for this, I guess since we do it one line at a time, the syntax tree is never going to be that large. Yeah, okay. So case, the set, let me copy all the cases here, right? And then we will interpret them accordingly. Not interpret, but we'll parse them. Okay. Yeah, we don't really have good tools for this in Kano at the moment, so it's kind of going to be verbose. Not very, that's not the right word. So basically, I have to do it live. Okay. Yeah, so I definitely need some sort of multi-cursor or something similar to make this a bit easier. Definitely on the to-do list. Something similar to that, so I kind of like the way Game does it. It's not exactly a multi-cursor, but it's a similar thing. Okay, and then, yeah, then we can just fix these. Okay, and then we put break. And then we're all good to start actually parsing. So some of these really are going to be unreachable. In which it shouldn't ever explicitly encounter them in here because it'll be encountered separately, you know? So we'll get those and then we'll put them all together and then just have them assert false for them. Or well, we'll probably return something because it could be user error that happens. So yeah. Alright. So set var. That is okay. That is what set var. Yeah. Why do I have two of them? I accidentally made two. That's my bad. Okay, so that's basically setting a global variable. So we need to do basically what we're doing down here, except we don't actually interpret it. Right. So we need to check this. So we can still use that expect. Yeah, this isn't going to return errors though, like this. So we're not going to use that here. well, yeah, we can really, we can return null, and then we'll just check for null. Why is null not a keyword? Or really a type? It should be. Let me add that. Okay, no. Yes, why is there no null? No null at all. Like that. There we go. Okay. Null is a very real thing. Okay. So command size is not equal to 3. Okay, that's not, well, let's see. If we want it so you can set it to an expression, it's going to have to be different than that. So, okay. Right. Trying to think. So what is, I don't think we need to really check that. So the next one is definitely going to be a config ident, but then one after that, it's always going to be an integer. We're not going to have floating point stuff that you can set it to, at least not now. But then after that, it could be something else. So let's make a node, right? Read. Equals create node. So we're going to need something for that. Create node. And what are we going to pass to it? So we need a left and a right, and then we need a value. So this is the root node. Create node. Let's just allocate for it now. Do we want to allocate? I'm trying to think. So yeah, we'll allocate. Size of node. And then we'll call right in here. We'll call create node. So let's do create node, and we'll pass the root node, pointer to root, and then we're also going to want I suppose the node type. So the set bar. Hang on. So how do we need to pass a node type as well. So that is the type that it's going to be. But then we need, let's see, node keyword. That's what it is. We're creating a keyword node. And that's for the root. So I think we can do that, right? This will just be void, right? Create node. So we'll take a node. And then it will take a command token. Command type. This is the type. Okay. How exactly do I want to say that? And then we have a node type, and this is node type. Yeah, I don't know exactly how to call it. Then basically we want to return, we want to set node, alright, how do we, let's look at the node. Up here, yeah, so node value, so we have a node value and a node type. Okay. Node type, yeah. And then based on the type. So this one is going to be, this one is, it's a keyword type. Which is where I thought I created that. Yeah, command type as keyword. So, so we need to pass really a node value. Is that right? Okay, so little. I'm trying to think how exactly that would work. Yeah, I suppose if we pass a node value, we can pass that and then be the value. Right. Hello, how you doing? Okay, no value. Yeah, let's do that. Let me change the order of this. So we want the type first. And then we want a value done. Right, like that. Okay. So let me change it. So tt set bar. And that's what we want to pass. So node type. Let's type. And node value equals. Well, then we need to switch on the type actually. Switch node type. And depending on the type, we want to do different things. So like if it is, we want to copy all the types. Yeah, all these. Okay, so case that. Okay, yeah, like that. That's all of them. Okay. So, that. Okay. Great. Great. And good. Okay. Alright, yeah, so in this case, we have keyword. So that's what we're looking at right now. So then the node value dot as keyword will die. Yeah, so we can set the type like that. I don't know if you can set it another way or how that works. Does any of this compile? Hello, shapeshifter, how you doing? Oh yeah, so node doesn't exist in that case, so we need to, let's see, we can do it like this. Mm. Yeah, we have to. Oh yeah, it's called node val. Use parameter. Okay, let's see. So create 1800 layers of abstraction ready to spin. Okay, are you ready for push-up? Sure, sure, sure. For sure, always ready. How much is that? It's like 1500, right? I don't remember. Yeah, it is 1500. All right, push-ups. Yes. I will do that 10. 10 of them. Okay, done. Soon I'm gonna set up a camera, so there's actually proof, you know. There's no proof right now, but yes, done. I did do it. You have to just trust me. Whoops. Shoot. Dang. Oops. Sometimes that happens. We're trying to undo it, and then it deletes everything. I don't know why that happens yet. Looking into it. Okay. Okay, there we go. Sliding. Stir. And as expert. Okay. Alright, so it doesn't like that. But I can cast it, right? 3 a.m. thing. It's 4 p.m. for me right now. What's that? Is that how it works? He is President Union now. Yeah, so I don't need to do all this actually. I think you can set it just like that then. Probably be asleep by the way if it's 3 a.m. That's pretty late. Yeah, so I don't think I needed that at all. It can really just be like that. Yeah, so it doesn't like this cast. We'll return the root and here as well. Okay. P7 that should be in there because we have command type. And that's one of these. So let me try something. Can I? I'm not used to working with unions, so kind of learning. Node val dot as keyword equals to the set bar, and then pass it like that. You should get to join your stream. Luckily, we're not asleep today. Well, glad to have you. Time zones can be pretty unfortunate, though. Yeah, okay, so I think I need to define it. All that as keyword equals set bar. Okay, then it compiles. So actually, I don't want to set to that. I don't want to set it to. Not like that. Set it to the 0 dot type. Then, yeah. Okay, and then we can pass it. We don't use command sign, that's fine for now. We might not need it at all. That should create the root node, right, as a keyword. And then, right, so we have that. So if the command size, we do need to check it actually. So if command size is greater than 3, then that means we have to parse the rest. So let's do actually command size. Let's see, equals 3. Then that means we just have we have the first one, which is like the keyword. Then we have the identifier, which is the variable that we're setting, and then we have the value. So that means we can just create 2 more nodes, and that's it. Create node root. Not root. So we need really to create a new node. So maybe maybe they should return a pointer to a node that we allocate. You know. So let's define that as main, right? And we'll set root equal to that, and not actually pass a node there. And instead return it. So return a node, a pointer to it, like this. Hello, Crow. How are you doing? Or Crow. One of those. Node equals no. Then we just return that. And okay. Say yeah. So root equals create node. Okay. And then we make a new node. So then, this will be left, right? Equals that. So left is the config identifier. So let's pass that. So we need the node type, which in this case is going to be node ident. Yo, Stan, how you doing? And then, yeah, we need to define a node val. We can just use val for that. Yeah, we can just reuse the rebuild mode. So we need, well, okay, that might actually break stuff. Well, no, not if we set it to the right type. Hello, Billy Bob Buttery Biscuit. I am doing well. How are you? Today. Oh, shoot, the bot seems to be going. Working on a text editor today. Kind of. Really, it's more the programming language for the text editor. Yeah, I can show. Everyone called you Stan? Well, yeah, well, that's kind of makes sense from your name, right? Okay. Val, I'm pretty sure I've called you that before. Okay, val dot as ident equals. So how do we do that? We need to make an identifier, which really try out the cute fish window manager. I've not heard of that one. Hi, raining day. How are you doing? Good luck with that. I've not heard of that one. So really, it's not an identifier, not this one. This one is one of the built-in config, right? So actually, we already have this. So let's use that. Use the config that is. Reno is back on Rust. Oh, okay. Nice. That is the text editor, right? You were working on it? Has lines and stuff? Very nice. Yes. I do remember. Is the code public? Okay. Yeah, so we use this one. Config variables. So that can be one of the so node config. So any one of the config variables. So it's similar to the identifier, but it's not the same. As config, sure. So we need to pass one of those. So in that case, it's going to have the label, which is that. So let's see how we actually are interpreting that here. I think we have an array of them. This public has a few mistakes right now that are still supposed to be fixed. Okay. All right. So value equals that. Yeah. So basically, we're doing the same thing as this, and this is to find the config variable, the corresponding one, and then we use that. So that is what we want the value to be. It's based on that. One would tell them to auto format on save. I imagine you need some plugin which calls to like one of the formatters or whatever. I don't think it's be that difficult. There's probably quite a few. It also depends on if you're using Vim or NeoVim. Because with NeoVim you'd probably use a Lua plugin, but with Vim you'd have to use a Vim script plugin, which I'm not sure if it like how that works with regular Vim. On NeoVim though, it shouldn't be too hard. Yeah, you do have to set it up, yes. Okay, so you compare that. Okay. Value. Okay, yes, this is for getting the value. I want to do that right now. Okay, view2 in. Google around, that's a good idea. That is how many problems can be solved. Which is getting nice, and that's a bit of a different thing. So we'll worry about that after. Okay. So what else do we have? So if it is the same as any of those labels, then yeah, I'm gonna set the I see. So there's I, not val, equals value. That's not exactly what we want to do, because this is more interpreting it, but we want to take the value of this. Why is there okay? That's I did. Well, no. All right. So we need to actually create the config var, right? And that will equal the dot. Let's see. What's it called? It's called the label. We'll set that equal to command1 value. And then we need to set the value of it. So var dot value equals vars I down. So that is the pointer to vars I. Actually, I think we can set this in here. So create the variable and set the label equal to this label. Label vars I dot label. And I don't know if that's what it's called, but the compiler will tell me. And this is for actually setting it, so we can get that. And that should set up that. And then we should be able to create this with that, right? So we need to set val.as config. Set it down here. Val.as config equal to var. Right. And that is what we can pass here when we actually create it. Let's see, val. And it is not an item, but instead a config. And that should create the left-hand side. And then at the end, we want to set the root.left equal to that, and root.right equal to the other. And this should actually set the left and right equal to no by default. Because that is very important when we are actually interpreting. Okay, so left is that. Alright, and then get the value, and we'll set node right equal to create node, and this will be a node expert, right? Just a single one. And the value, so val.as expert equals value. And I think that's all I need. So val. Okay, let's see if it compiles at all. On variable left and right, that's fine. Incompatible types. Alright, expert, so this needs to actually be expert, right? And then and set the dot value equal to that. Which I might not need that. It might just be able to be an int. But we'll see. Config vars from type in equals var. Let's see. Mm. Right, it's actually vars. That's why it thinks it's an int, because that's like the default type. Okay, yeah, we can do it results like that. There we go. Did you mean val? I suppose I did. Okay, unused variable right, unused variable left, and that is it. So let me make sure the name's all right. So this is a config var, right? Config vars. And that is what the array is. We have the label and the val, so that is right. Let's see, yeah. And then here are all the variables. So this is the label, and that's the value. So we set it, we point it to this, essentially, is what we are getting at. Okay, let's go up here, parse command. Okay, so we got that, and this should pretty much be the parsing of a single one. So like set var, syntax 0, something like that, should be pretty much this. So we need to then set root.left. It's left. And it's actually root arrow. Set to that. And then we'll just break. And we'll return the root at the end. So we need to do more complex stuff if it's greater than 3, because it's just that. Because if it's greater than 3, then we have to actually get like the whole thing. So we need to probably be able to extract this out as well, at least to an extent. But yeah, that's pretty much it for that. So that should compile. Yeah, we don't get any warnings. So let's see. We need to actually do stuff with that though. So I am going to move this up here, and then just return. No, like that. And then I'm going to have a new thing. So this is gonna be yeah, we're gonna basically interpret command, and we need to pass the node into it. That's root, and that should be about it. Well, we'll need buffer instead as well. So interpret command. Let's make that. Interpret command. There's probably should call these separately rather than in here, but it's fine for now. And then root is a node, so root. And that's what we're gonna interpret. So we're gonna sort of recursively call this to traverse the tree. You know? So if root equals no, then we want to just return. Okay. Let's see. So then, whoops. We should be able to call this, right? Interpret command. That's buffer state. Then we'll do root left. And I think you do left first. And left. And then yeah, once they are null, then we do this. So we're gonna let's see. We're gonna basically how do we want to do this? I've not built an interpreter like this in some time, so I don't know exactly how it all works. Basically, we need to switch on the type of the root. Switch, not switch. Let's see. Root type. So we need to grab all of the types. So the types can be any one of these. Alright, so that is what we'll switch over. And we'll obviously interpret it differently based on that. So we've got that. Let's see. That. That. There's no multi-cursor or anything, so this is the best way to do that for now. Okay. Break. Alright, so I want to get, let's see. So keyword. So that is, it's usually going to start with a keyword. So the rest of them, we don't really necessarily need, right? You should use tree sitter, because if not, you will need to make the single most difficult thing. Probably will. I'm not gonna think about that too much right now, though. Like LSP stuff. That's down the line. Okay, so case keyword. Then we have to actually switch over the keyword type, right? So how do we get that? Root value type, something like that. Let me look at how the node is defined, right? So yeah, we have value, node val, color creative types. Yeah. Yeah, that is down the line. It's not super important. Like, and so we did pretty well without those colors. Okay. So yeah, we need to actually get it as command type, as keyword. That's what it's called. So as keyword, and we'll switch over that. So it. Yeah. Okay. So node value as keyword, and we'll switch over that now. So another switch statement. Case, and this actually has quite a few different things. What you could do with LSP is connect it to syntax highlighting and add the new types as a new color. Okay. Yeah. Yeah, but I'm not going to worry about LSP stuff until a lot of other stuff is done first. Yeah, and that's not something that I really use, so it's not super important to me anyway. Okay. Yeah, some of these are not used though. Hello from Windows. Are you permanently on Windows now? Hello. 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 How you doing, by the way? Planning on using PowerShell and Windows stuff, not going to use WSL. Okay. So you're not using Linux at all anymore? Or what? What's the deal with that? Alright, set bars. That is the one that I'm working on right now. Nope. Interesting. Let me try MSys, I suppose. If you need a Linux thing. Okay. So what made you decide to leave? Is it NixOS? This is kind of boring. And alright, one more. Alright, there we go. Yeah, so most of those are gonna be unreachable stuff. Yeah. And if they are reached, then that means there was an issue during the parsing. So okay, so set var. So if we encounter that, then we're gonna look to the left to see what variable we're setting, and then we're going to look to the right to see the value that we're going to set it to. So we're going to do a similar thing to this again. What we had here, where we loop over, but we need to actually get, yeah, we need to get what the value is. Well, we don't really need to loop over it like that, do we? Because we have the pointer to it. Because it points to that, the config var. So what we can do actually is get the root left dot value. Right, so root left dot value, and that will have the pointer to it. Right, so that is a config vars. Okay, dot value. So we need actually dot as config, and then we can get yeah, we can get the config var. So let's do that. Keepfish isn't even working, so we're going for awesome WM. Okay, awesome WM is very good. I use it, as you can tell. So I think it's a good choice. As config. So this will be the config var equals that. And then we can set, if we just change the value equal to the right hand side value. Okay, value as expert. So let's just assume it's an expert right now. And that is what we inject. Okay, so this one should always be this, but this one might be a binary expression, right, where there's actually an operator and such. But for now, we're just going to assume that. Let's try to build it. Right. Yeah, there we go. Var. It's var value. I should have called value because I call it value everywhere else. Type in from type expert. So yeah, we need to actually get dot as expert dot value. Okay. Yeah, and this needs scope. Places. There we go. Whoops, that needs to be equal. Not equal, not assigning it equal to it. Okay. Just use GNOME and forge TWM. Okay, compiles. So let's see if it works. It's probably gonna say var. Set var. Syntax 0. Okay. It might have actually worked. Hang on. Equals zone. Set var. Syntax 0. Okay. Actually, I don't know if it works. But okay, hang on. Let's set var inlet to 8. Okay. That actually looks like it worked. And I wanna I'm gonna write log and make sure that it is working. Write log. Working. Make sure it's calling this actual one. Set var inlet 8. Working. Okay, so seems to actually be working. First try. Okay, I'm pretty happy with that thing. So, okay. Now we go. This as well. And then, okay, so we can start working on the getting the actual binary expressions to work, because those do not work right now. So if oops, you know what? We should actually return at the end here, because we know that we're going to be at the end in this case. So we're going to just return. If root right dot type arrow type equals node expert, then we can just do this, right? And that's totally fine. Whoops, now I messed it up. There we go. Okay. Otherwise, else, it's going to be a binary expression. So we have to take the left and the right, and then sort of interpret it, right? And it's going to need to be done recursively, because it could be, however long. So, yeah, I'm going to do that after a quick break. Whoops, not time. Yes, I'll be right back in about 3 minutes. Give me a second. Okay, I am back. So let's see. So I can't actually parse this right now, but I want you to build the interpreter part and then build the parser, just because. So yeah, It's going to be a binary expression. So we know that the left-hand side is always going to be just an expression. So we can just set, we're going to need to basically accumulate a value, right? So it can start as the left-hand side. Let's put it up down, like that. And then we'll value plus equals, let's see, interpret expression, right? So we'll make a function for this, and we'll just pass the root, right? So maybe we should even set it equal to, I don't want to, and basically, yeah, basically we're just going to need this again. So we'll get the left, and then the right. Yeah, okay, so let me try to make that function. Interpret expression. So it's not going to actually return void. Okay, so we have a node. Okay, so the left, we always know that's going to be a node, and then it's going to return a value, an int value, for now at least an int. So int value equals the not the node, yeah, dot value that has expert dot value. So yeah, the left, well, hang on. Yeah, so the left is going to be a regular expression always, not regular, but an expression always. Okay, and then the right, if node right, dot type, not type, but arrow type. That's an arrow as well. Arrow type equals node bin. Then we need to recursively follow this. Otherwise, so maybe actually two does not equal. Then we'll do return value plus node right value dot as expert dot value. So that will get if like we have 5 plus 10 or whatever, then we can get that value. Okay. Right. So interpret expression root right, but root right could actually be an expression. So we don't necessarily want to look to the left like that. So yeah, and this is actually not quite right. We need to get the value as a binary expression and then get the left or right of it. So this is, yeah, this syntax is not quite right. So hang on. Yeah. So we can't get the, we need root right. Let's set the node parameter. Node equals root right. And then we'll do it based on the node. So node node value dot as bin right dot left yeah dot left. How do we build this actually? Let me look at an expression. How is it built? Okay, it's just an int, and that's not quite right. So really, that's not what we want, because it could be branching out. So they really need to be binary expressions themselves, right? And then there needs to be the value stored somewhere though. So how do I do that? Right. So somewhere it needs to be one of these expression structs we have here. Really could just be an int, but it's fine. Yeah, so how do I want to do that? This isn't really something I've done before, so kind of need to come up with it. Okay, so we could have trying to think. So okay. It's not exactly right. It's up of the tree, but there's no actual value to the tree. So can we use? Not really. This really needs to be either a binary expression or an expression. So what if we define this, right? Something like that, and then do that. then we can make a union, right? These are, what would they be called? So basically just expressions. So it could be either a binary expression, thing, or an expression as expert. And then this is going to be an expression, which I should probably name that better, but I'm not going to get expression. Left and right. Okay. And it can be a pointer, that's fine. Should it be a pointer, actually? Maybe it should just be a bag. Yeah, okay, sure. And then, yeah, so the right, then, yeah, so it could be built out from that. But then we need the type of the left and right? Because we don't know what it is, so we need, like, you know, expression type. Let's see. Berlin. Expert. Val. Okay, something like that. So I feel like this is more complicated than it needs to be, and I will be thinking about it. But yeah. L type. So that name is probably too long. Okay, so we need to basically build it like that. So then, type an expression. We have the node let value. Okay, well actually the node, it's going to be a binary expression. So we instead name node value dot as bin dot binary expression dot left. So left left dot as expert dot val. Okay, so that's kind of a long thing, but that's basically what we need. Because the left is always going to be one of those. So we need that here as well. Root, right. And then value dot as binary dot left dot as expert dot value. Okay, so yeah, the left is always going to be that, and then we can value plus equals that. Okay, and then we need to actually set the value. So r dot val equals value. Okay, and here we need to do this. So if the type is unequal to that, then we set node value dot as bin dot left. Oops. Let's see, dot as expert dot. So it's that. Otherwise, we need to just recursively call this, right? Else interpret expert. Yeah, on the node value as bin dot. This seems to be left, or this seems to be right. But then that's on a node, so that doesn't quite work, does it? So maybe this isn't right. And yeah. So maybe we should take a binary expression instead. Or an expression, right? So that is what we pass. So in here we pass the right hand value. Right. No, not anything. Pass that. So we don't actually need this thing, because that gets handled. So we can just set value equal to that. And then that's good for that. So pass that here. Here from YouTube. Welcome. How are you doing? Okay. So we pass the right. And that should be right dot as big. Let me interpret that. So we set value plus equals that. value plus that. Okay. I think something like that is right. So, type for argument of that. It's a binary expression. Okay. So we have to, I think we have to pass the right, so then we actually have to initialize it. Equals node value dot add bin dot left add selector dot left. Yeah, let me just plus equal. Okay. Expression pointer. Okay, yeah, we need to pass the pointer to this, that's fine. Yeah, node doesn't exist, it's called extra. So that is a more appropriate name for what it is. It's a pointer as well. Expression has no number named value. Right. So we don't need that. Just like that. It does need to be an arrow though. What commands are you working on? CLI? No. So right now, I am working on for text editor commands. Like here, you can type in a command. Basically, it's a scripting language. Is what I'm building out of it. So this is like the parsing and interpreting is what I'm working on for the text editor still, but really it's kind of building a scripting language. So like that, yes, it's pretty much exactly like that. I'm gonna type binary expert. Yeah, so it doesn't know that. Hey, where did I? Yeah, 61. Can't just jump there because I forgot I didn't re-implement that. Let's see, right here. Binary expert. And this needs to be extract. Let's see. It's been as incomplete type. Okay. But then I want it to try to reference it before that, but that gets a little confusing. Do I use type down? Because I need to include that in itself. I need that. No, but that's a unit. Then move this down here. I'm trying to think of ways to make it work. That seems even worse. Alright, maybe this isn't the right way to do this. What else? Okay, let's see. How can we... Basically, I need to reference it before it exists. Let's see, reference or Maybe I'll just put struct, because then it probably has more answers. Struct declaration, let's see. Forward declaration, yeah. So struct. Alright, I think it has to be a pointer if you want to do it like that. So let me try. This isn't even a struct, so what am I doing? Okay, yeah, it doesn't like that. Let me try, moving this back out there. And then, yeah, so that should work fine. Then we need to put that there. So, expert, expert. How's it going? It is going well. How are you? Start in expert. Uh-huh. Yeah, and then make it a pointer to it. Put it down here. Let's see. Expression is no memory value. Ah, yeah, because it needs to be as big and left, right. Okay. Or as expert. Okay, so I think that works then, if it's a pointer. Windows is not bad. That is blasphemy. I'm afraid you need to leave. Okay, let's try this again. So, expert dot as bin. Yeah, okay, so expert is always going to be a bin, so we can do that. Yeah. Expert as bin. This needs to be as expert, right? No, as bin, but then the right is as expert. Yeah. Thing about Windows is Microsoft making ads and always doing everything wrong. Yeah, well that's a good part of it. And it's proprietary software. Right. Is that gonna work? Alright, so I guess you use. Okay. Most of us things are on Windows. Yeah, but Windows itself, it's not. Alright, so it doesn't like that. Let's see. We'll use, let's see. Mm. Mm-hmm. Matrix reference. Alright, so that's most of the problems here, but what is as expert? Yeah. An expert, okay. So which is n. Again, star return. Yeah. So let's just do plus equals and return like that. There we go. Okay, so yeah, now the issue is like the forward declaration stuff. See, forward declaration. See, I want a good example of it. Let's see, maybe AI will help. Yes. Struct forward. Mm-hmm. Can then use pointers to that. Yeah, that's what I'm trying to do. So, track binary expression. Use that. Let's see. What's that thing for that? Okay. Let's define in. Oh, this is like is this? Yeah, let's see. Mm-hmm. All right, let's see. I want to find something that is okay. Um. Okay. Let me see. Let me try something. Let's ask ChatGPT if I can help with that to make it work. I won't be able to, but you know. This line numbers, that's okay. You make this C code. Let's see. Okay. I think that's still not right. Because, yeah. The texture are supposed to be inspection. That's not gonna work though, right? Yeah, that works. Yeah, that's not gonna work. Yeah, there we go. Yeah, doesn't know what that is. Well, being it's very easy. No, it's very cheap. It's because it's not there. Show specs using the effect. Hey, not p-patch, yeah. There you go. Screenshot. Don't think it knows what I want. Syntype Unix born. Use an undefined type. We have expert defined, so we don't have to do that. Easy upvotes. Yeah, those don't matter, so I don't care. Don't care about updates. Lim 4K follow. I think it's Lim. It might be an I. One of those. Where? There's expert. Got it. And it doesn't like. Let's save. Okay, so how can I make that work? It's been done right. Okay. I don't think that's right. Because the name is based on Nano, that's why it's Kano. But the emotions are Vim ones, yes. Well, because I like Vim better. But the Kano name sounded good, so. It is ironic though, yeah. Okay, where is it at? 14, that's right here. Nope. Mm. Be that right. Arrow right. What are you working on now? I am working on the command system, right? So it's like a scripting language basically, like Vim script, that kind of thing. I'm working on the parsing and interpreting of expressions in that. So like right next 12 plus 5, something like that. You know, that is the idea right now. Okay. Okay. Mm-hmm. It's a pointer. It was cool using an editing, yes. Except when it deletes half the file and stuff randomly. We embed Lua to it. No, I'm planning on using this instead of Lua. Yeah, because I felt like making my own thing, because why not? Yeah, so I don't want to pass as bit. I want to pass the way. Has been thought. Lua has an awesome C API. Yeah. Probably do something else with Lua, but not for this. Because it would be cool to, you know, make something with it. Mm-hmm. Expert has been right. Doesn't like that. I'm not sure it's gonna work like that. Right. We don't need this one though. We need. Mm-hmm. So we need 2 pointers. What features are you working on? I am working on the so that we can do like 12, 15 plus 123, something like that. That is the idea. Trying to interpret it, right? So from a syntax tree. Let's see. Why didn't make an LSP? And yeah, TUI text editor, it's hard to make the next GUI one. Well, I've not made a GUI one, so I don't know if that's true. No, there's no LSP. I'm not get to that yet. Okay. It's struct. Yeah, so that's not like it's not gonna work like that. Mm, yeah, it doesn't like that either. Maybe I'll do that. I don't know. I don't know too much about how those work right now, so I'm not sure. Mm, I do that. Yeah, but can you do that with a? Can you do that? Maybe I'll have to do it a different way. Rather than a E. Okay, now you have an expression. Expression. Doesn't have to be pointed out. Right. So then, yeah, L value. I don't know. Let me try that because I can't get the forward declaration stuff to work. Okay, I guess so. Then stuff's gonna stop working. It spans big anymore. Well, we need that one. You know what? Well, we need that. I don't know how it works yet. So how's it set up? Let's see. Yeah, we need. Forgot. Can I do that, or do I need to extract that too? Okay. That's very right. Okay, right here. So expression right, R value. Let's see. Hello, how you doing? Not really the right value, but instead the expression right, not right. No, this expression left value. How are you handling operator precedence? Not right now, because I just started on this, so I'm not thinking about that yet. I want to get something working just like, without that, and then I'll worry about handling that. Okay, so good. I am doing good myself. Okay, so then we need expression. We don't need this has been. So if the right, let's see, how is that? So expression right. All right, so that's not exactly the right thing to check. We just need to check if expression right equals null. Then we just need the right value. Our value. Yeah, our value. Our value actually. Otherwise, we need the interpret expression on the right one. Yeah, and we treat that as the expression. Okay. That is down here. Node value has been. Yes, that's not. Has been dot no, it's a dot. Okay. And then this we need to pass value has been. Just the yeah, as been. Okay. It's the pointer though. It's to be dot value. Okay, so it compiles. I don't know where it's going to work at all. And we don't actually parse it. So yeah, hopefully that is the interpreter for it, but we need to actually parse it now. So here is parsing when it is just two values, right? A left and a right. No, when it's just a single value. That's what I'm going to say. So else, otherwise it's going to be greater than 3. So we're going to have we need to get the operator type of the next one. So it can be, plus, minus, or whatever. And then, I forgot to actually consider that. So I'm just adding with the other ones. So I'll need to think about that. But yeah. And we need to basically build, make a binary expression with the left and the right stuff. Let's do that. So yeah, the left, it's always going to be this first one. So make a binary expression equals. So we can set dot L value. So we don't need the left at all. We just need the left value. Yeah, so that is a thing actually. So we can change that. We don't need this. We just need L value and right value. Okay, yeah. Well, so does that mean then we don't need the right value? So that's the way to do it. Okay, well, I'll think about that, because I'll have to change stuff to do that, so I don't have to do it again. Okay, let's see if I can get this work. That can probably be shortened as well, but okay, whatever. L value equals, yeah, so we need the value. So that's always going to be the left value. And then for the right value, we don't really want to set that. Yeah, okay, so we need to then check the next token. So if not, it's command 3, so that's the next one. To be type plus. So for now, I'm just gonna check that. And return no. So we'll just check plus for now, and then worry about handling other ones later. Okay. We need actually expert, right? And actually be expert like that. So I don't know if we can do this. But something like that. Okay. Yeah. Something not just in it. But it's a struct event. So I should probably change that, honestly. Whatever. Okay, so yeah, we have that. And then we need the next one as well. Or the int. So it has to be an integer. Yeah, I'm just return null, so then we'll just check if it's null. Yeah. We can worry about proper errors later. Okay. So then, if there is more than that, then we have to basically interpret it again. You know, or parse it again. Otherwise, let's actually do if int size equals 3, 4, 5 equals 5. Then we want to do this stuff. Otherwise, we want to basically call this again. So we'll make a function for it, probably. Else blah blah. Okay, so if it's that, then we just want to take the right hand side and set the value to that. So it's actually let's try something else here. So let's set expert.l equals expert to value. Right. So still do that, but then 0 initialize the rest of the stuff so that it will be set to null and such by default. Okay. For dot r value equals expert of to int command 4 dot value. We'll convert to integer, and then that's all we have to do here. Okay, so we need to basically append that. So we need to make a node. Set the right node to that. Okay, so right equals node, node binary, and we have to pass expert. But we need to actually make one of those. So value. We can set val.as equals expert. And pass val there. There we go. Okay, so that'll create the node. And we can set it to that, and all that should be good. So that's gonna actually get in here. But let's see what else. Alright, so that's the only error we got. So we need to basically do this. So we can do parse binary expression. And let's see, what are we gonna pass it? We need the tokens. So I guess we could just offset it by whatever that's like command plus, in this case, plus 2. Right, so then we would start, well, hang on. Let's make this a binary expression. And this is going to return a binary expression, right? Yeah, so we'll just kind of take this stuff and put it in that function. Expression, parse binary expression. Why is it in it so much? Okay, actually, okay, no, it's too much, I think. Indentation's kind of hard right now. Okay, so expert, and then we don't want to set it to that. And instead we just want to return expert, right? And this we want to say expert right equals that. Okay. Right equals that, and we don't want to set it to that. Let's create it. So What do we pass? Did we pass the tokens? Okay. So yeah, basically we need command. So let's just start it at this first one. So that's the first value. And this one is that. So that's the plus, right? 1, then 2. And we'll pass the size. Yeah, the size minus that. 2. And plus 3 is what we want there. And here we want to do, let's see, when we call it, here it is. We want to call it with command plus 1. Because we just want to chop off the, well, plus 2. Because then we want, yeah, plus 2. And then command size minus 2 is what we'll pass there. So that's what we need, is command and command size. Yeah, so just like offset. I don't know. It's command size minus 3. Yeah, so then we can interpret the rest of it. Right. We still need the, that's 2 there. Okay, and then we want to actually set it to root right equals create node. Let's see, node primary expert, and you need to actually set val as bin expert and pass the val there. There we go. Okay. Forgot. Semicolon? No. Okay, it doesn't like that. Seems to be equal, yeah. My bad. Uh-huh. Right. It's really dot, right? Okay, this, I don't think that's gonna work. Yeah, can't quite do that. There had to be a point. I don't know if it's gonna work, but it's not. Yes, we can't return null there. This needs to return just, bin spur 0. It's just like, empty one. We'll have to check that. Okay. Save. Val undeclared. Uh-huh. Why is it undeclared? Oh, it's because I said it here. Yeah. Can't do that. Incomplete type. Yeah, so that needs to be a pointer. So that's not going to quite work. So it's going to have to be allocated. Yeah, okay, so let's make it, and we'll set it equal to the, yeah. So right exact, we need to use arrows then. Here, when we actually call this, to be a pointer. Okay, whoops. And then we can return null. Nice background, yes. I do that quite a bit. Yeah. Made it myself, in case you couldn't tell. Okay, I compiles. Don't think it's set $, 8, 2, 4 plus 4. Set call, nice. Okay. Saw the password. What password? Let's see. That still works. Okay, so it's just when I'm trying to parse that, it doesn't. So is it in the parse or is it in another place? So your credentials? Huh? What credentials? I don't know what you're on about. I don't know what you mean exactly. Okay, command size equals 3. Okay, let's try to figure out where it's breaking. So let's see if we actually get this properly. Try to output. Oh, the oops. Okay, okay, I see what you mean. I see what you mean. Okay, let's try to get the left and right hand side, right? Expert. Expert L value. Expert right value. So we should just have those right there. See if we can output them. We need to get actually dot value from it. Whoops. It is a pretty serious leak to see my wallpaper. Not done. Okay, let's try to do that. Set bar. 4 plus 4. Okay, so we did get 4 and 4, so that worked. So it's not here, it's when we actually interpret it. Your first clip. Yeah, I think so. I think that I have not had any other clips. Also, how you look at chat. What do you mean? Interpret it. So it's probably broken in here. Do you have another monitor? Yes. Yes, I have a second monitor where I have all the Twitch stuff and OBS open on. So that is when my mouse goes over to the side like this. It's because I'm on the other monitor. You can actually see because the oh, maybe you can't see it. Yeah, you can. My mouse, like, it's over in the blackness over here. Because it stopped. It was the only possible situation to make a clip. Yes, true. Alright, let's see. Can we, write with this value? And let's see if we get that. Which I'm assuming we don't. Fine. Set bar. 4 plus 4. Yeah, no. So, let's see. We get here. I'm assuming we'd be able to get to this point. Okay, let's see. Set bar. 4 plus 4. No. Okay, so... Very funny clip. Ha ha ha. And I want to see what this is. What the very funny clip is. Oh, yes. That is very funny. Very much funny. Just a clickbait. No, it was funny, though. So it's not clickbait. Okay, anyway. Alright, I have to go, actually. Like, right now. So let me see if I can figure out where it's coming from. I'll probably, debug it some. And also read more about parsing. Like, off camera. See if we are here. Let's see. Yeah. So I want to figure out where it's from before I go with this forward. Alright, yeah, where does it break? Okay, root value. Alright, so we don't actually get into this point. It's root out right now in the valid network. I didn't need that in mind, actually. I'm assuming you get to that point. 5, 8, that's 8. No. Okay, so that's interesting. Command. So why does it not work there? Because we do get to that point. So that's kind of sus. Alright, so something wrong with the root. So I'll have to look into it off stream, and then next stream we'll talk about what happened. Let's see. So I don't really want to commit this because obvious reasons. So I'll probably fix it off stream and then make a commit later once I get that part actually working. Yes. Kind of sus, yes. Okay, so yeah, thank you for watching, and I'll see you guys next time.